Welcome, Sasha. Welcome to EDA Summit. Fantastic to have you with us today. And we'll spend the next few minutes talking about the event-driven journey at Grasshopper. But let's start with knowing a little bit more about you, a little bit more about Grasshopper. So would you mind giving a quick introduction to Grasshopper, the business, the high-level technology, and your role there?
Hi there, Sumit. Thank you for having me here. I'm Sachar, CTO at Grasshopper. Been with the company for a long time now. Started as a network engineer and now trying to drive the tech direction for Grasshopper. Grasshopper is a high-frequency trading firm, and we've been around for a long time, headquartered in Singapore, and been using event-driven technology for, I think, close to 10 years now. At that point, it was called something different, and it was an interesting journey to start using that technology. It helped us to overcome some of the challenges that we faced, moving from a vendor solution to our in-house built software. We looked at that point purely real-time messaging, moving off market data, orders, and then any other data that might have been relevant to trading. So I think that would be the short intro, what we do and what I do at Grasshopper.
Thanks. Yeah, I mean, I've had a long association with you, so
Yeah.
it's been fantastic brainstorming on those whiteboards. But just to go into a little bit more detail, so trading platforms are very real time. So from pricing, as price changes for any particular asset you want to buy and sell, for the order management or the algorithms to act on that price, and that then becoming orders and that becoming trades. So what all are the kinds of data that you move real time? Can you give us a little bit deeper perspective into how these events are going across multiple systems or sites, and what kinds of these events are, what volume do you move them at, what latency requirements, just to characterize the problem a little bit further for us?
Yeah, no problem. So when we started looking at it, the main question we had is like, how do we move data across multiple locations in the world over fairly slow WAN links with very little bandwidth? And this is like 7 years ago when, especially then, WAN bandwidth was extremely expensive, especially in Asia. So we looked at how can we send these messages across in a very efficient way, especially how data is generated. We normally have multiple subscribers listening to the same source of data. For example, for market data, you can have up to 100 subscribers who want to see the same market data. And of course, we don't want to send this hundreds of times. One option could have been multicast, but over WAN links, especially these that are less reliable, that's a bit trickier. So we looked at Solus as an option to ship this data across, and this works well. There's some WAN optimization there. So that's the market data. It's real time. Gives us the flexibility to very specifically subscribe to a certain symbol and a certain depth of what you want to see in your book, or level 1 data, level 2 data, or level 3 data. Besides that, there's the order execution part. So when we send an order, it could be from a different location. We want to also be able to publish these events to the UI of a user or a trader in this case. There's fill messages for when a fill is executed by the exchange, as well as reference data. For example, like, what does this contract mean to us? What's the price relation? Things like these, which are served by central services running in for us in Singapore. So that helped a lot. We also use it to make sure applications are up. So we send heartbeat messages. Um, and yeah, having such an event-driven mesh allows us to get any event anywhere fairly easy. So it's easy to allow somebody to write a simple subscriber and say, okay, like, if you're interested in this event, you can just subscribe to it, act on it, and publish something on this specific topic hierarchy.
How was the journey, right? I mean, you mentioned topic hierarchies, and in the early days, you would have probably a few applications, a couple of publishers, a couple of subscribers in one part of a domain, maybe at a site or two. And at that point, as you mentioned, an in-house solution, right? So to developers, it's always like, okay, when my little messaging system works, why do I need to have this whole event-driven capability, which may sound like an overkill on day one? So how was the journey like? What were the challenges, both in terms of people challenges in getting adoption with with developers who are very, very good and very experienced and also very opinionated? And what were the other challenges that you faced in your, again, 7-year journey?
Yeah, so it was an interesting journey, and especially I think in the beginning it was the buy versus build question. Like, we can build this, and engineers love to build. But is it something we should focus our time on? Like, are there people that know messaging and event-driven architecture better than us? And there are, like that's why we partnered up with Solus to say, okay, like, if we don't have to focus on that part, we can focus on the other aspects of our systems that are more important for us and likely to generate more alpha on that side. So that was one point. I think being a network engineer, being able to just put an appliance in a rack somewhere and kind of forget about it was a big plus. It's much easier than having to deal with software and multiple servers to deal with that redundancy and performance throughput that an appliance can deliver. And the other thing that helped and how we approach it was to push for a unifying way of how applications can talk to each other. I think now you see a lot of APIs, and I think when did that start? Many years ago, the microservices and an API layer, and I think messaging in that sense is fairly similar in that you have some way to communicate, and this is all agreed upon, and makes it easier in the long run to change and extend your application. And I think that was one of the biggest selling factors that allowed us to convince some of the engineers that were in the fence here.
Got it. And when did you adopt the topic taxonomy standards? Was it from day one, or was it after a few iterations? You said that, okay, this is how the hierarchy looks like. These are the market data messages. These are the orders. These are the trades, and this is the metadata associated with them, so that this publish, subscribe, and filtering, especially in a distributed environment, becomes easy and predictable.
I think, and I know that you were part of a lot of these conversations that we.
Those are difficult conversations. That's why I'm curious.
I think that they're pretty much still the same. So I think what at the end of those discussions ended up being decided are still in place. I think you helped a lot in making sure that hierarchy is correct and extendable. So we're still on version 0 or topic hierarchy, and we've added topics, of course, but the gist of how we designed it is still there, and it helped a lot, especially when we moved onto cloud as well.
Interesting. Yeah. So the cloud journey, yeah, since you mentioned that, so I'll be very curious to know that, again, a trading platform which is latency sensitive, you're deployed in Exchange, colos, streaming all kinds of data there, taking decisions, very microsecond latency requirements. and then you're using cloud. So what kind of systems, what kind of applications run in the cloud? How do you, and I know you're still in Colo, so how do you get that hybrid cloud capability going? What data, what applications, what plumbing?
Yeah, so it's all about latency, and the moment it leaves a colo, it's kind of not fast enough anymore. So we made a clear decision that if it's not latency sensitive, can we move it to the cloud? Like, so for things like market data capture and historical data, some of the risk services, and anything that is a few milliseconds and higher, we made the decision, okay, we can run that in the cloud, and that should not be such a big problem. We leverage GCP a lot, and that global approach of networking is quite easy in extending, say, your on-prem infrastructure onto the cloud. So that helped a lot. It was interesting to see how to interconnect or extend this event mesh into this platform as well.
Yeah, so again, my understanding is that while you, for low latency reasons, you're using, at least from a Solus perspective, hardware appliances on premises, but in the cloud, you're using software, the software brokers in GCP all connected into a mesh. But how did you send information back into various GCP systems? What GCP technologies, since you mentioned GCP, are you using? And is this just storing of market data? Are you doing any historical analytics or anything? What do you do with the data once it's there?
Okay, so we leverage data flow a lot, which is based on Beam. So how it works is we have our publishers on-prem, so they would generate market data, for example. This is then published onto the message bus. Since it then does go into from on-prem to GCP, what we do to ensure that we don't lose messages, we promote all this to persistent messages, and then push it into this event mesh on the GCP side, where we have a data flow or multiple data flow jobs listening to these queues and processing this data. And then how this is done and the reliability is extremely important, since we're, especially for level 3 data, which are snapshots, we can't lose a message without having to replay or rebuild a book. And so having 100% guaranteed message stream is extremely important. So we have a data flow job, listens to queues and scales up and down based on the amount of data in these queues, processes it, and then we store it into BigQuery. And we use BigQuery as our data warehouse and run backtesting strategies on this analysis, and have this as a platform for traders and developers to really use this data.
Interesting. So again, getting a little bit technical here. So as you get this data into these multiple queues, so you would need, because you guys move a lot of data. So what would be the sharding strategies or philosophies as you send this data? Like how do you stripe this data across those multiple queues and hence into multiple data flow jobs? Is there round robin? Is there some more sophistication around it?
So that's a bit tricky, because sometimes for certain exchanges, a lot of the volume is done by, especially for stock exchanges, is that a lot of the volume is done for maybe 5 to 10% of the names on that exchange. So you can't nicely round robin or stripe over names and load balance that way.
So with names, again, you're saying trading symbols, right? Because we have a lot of...
say Apple or Netflix. I'm sure Netflix is trending now. not in a good way. So yeah, so that makes the balancing a bit harder. And at this point, it's like for a busy exchange as TSC at peak volumes, it opens and closes. You're looking at roughly 500,000 to 700,000 messages a second, which we need to process. These arrive in a queue. The nice thing about this queue, of course, is that we don't have to, on the processing side, have to scale up as fast as the queue grows, right? Like we are okay with delays, and we insert this data in a batch process anyway. So it's not that it's like we need to process data at line rate. So that helps a lot. What we do is we have a list of all the names, all the symbols on this exchange, and we allocate these as to queues every day. So we spread it out over queues, and then we can assign these workers to specific queues. And we've had a few discussions about this to, like, is this the best way to have many queues with hard-coded topic names, or should we use wildcard subscriptions? Say name 1 to 10 here, name 10 to 20 on this queue, so that it's a bit cleaner. But I think due to some of the logic in our job, making it hard-coded and assigning it to the queues made more sense.
Yeah, and again, it's up to the use case, right? And from my perspective also, because the volumes in your business change so dramatically across these different symbols on a day-to-day basis, depending on the news of the day, the ability to reallocate which topics go to which queues on the frequency that you like. I mean, you can do it at a daily basis. You can do it even within the day, whatever, as long as, again, you can manually do it, you can hard code it, or you can even have symbols based on the volume that you get from the colo. You could kind of reallocate these things. So sophistication could be built that way. I'm sure you've done a lot of those things, but it's a very interesting problem, like high volume streaming into cloud and then processing it with data flow and BigQuery.
It is, yeah, it is, especially since it's you don't find a lot of information on the internet about it. Like most use cases are fairly different from the financial market. So it was a lot of like speaking to Google, speaking to Solus, and really working together to say, okay, how can we solve this challenge, which was a great process.
Yeah, I know the discussion is interesting, right? Because this is not like, is this picture a dog or a cat? It's a slightly different problem.
yeah, it's completely different.
New to the big data or the machine learning AI, the kind of research that has gone in the cloud world, especially GCP.
Yep.
Terrific. So, Sachar, you've been a practitioner for a long time. You've done various roles. You've grown through the ranks, and you lead this super brainy, sophisticated technology organization. So, what would be your advice, reflecting back to other CIOs and CTOs or chief architects who are building or transforming systems to become real time? What would be related to patterns, related to process, people? What would be your advice to them?
It's a great question. And I'm always reflecting about this and thinking, okay, like what could we have done better? And I think focus on documentation, I think, is one thing that always helps. Like normally you're busy, you have a crunch, and you get the product out and you're like, okay, done. But try and make sure you allocate time to also have the process documented. Put some time on observability and monitoring to make sure that these systems work well, especially for something like an event mesh, which turns into black box pretty quickly and gives you a lot of freedom. Make sure that you do know what happens to that system. I think it will help a lot in the long run. And also empower people, give them the freedom to experiment and try out new technologies. Like having something like an event mesh can do a lot of things. Like the last thing we've used it for and made it a lot easier is to build a containerized based test up environment for all our developers where they can spin up their own environment of our trading applications. And in the heart of this sits this event mesh, which makes it very easy for everything to communicate with each other. And this was kind of done through an experiment, and then we grew along the way. So I think those are a few things to keep in mind. And don't be afraid to try out things, and if they don't work, scrap them quickly.
Fantastic. Great advice. Thanks a lot, Sasha. Thanks to Grasshopper for and you for sharing your thoughts on this interesting topic. And innovations will keep happening, and may the best technologies win.
It was my pleasure. Thank you so much, Sumit. My pleasure. And indeed, like I'm looking forward to working together for a long time and see where the road leads us.
Sounds great.
All right. Thank you.
Bye-bye.